Connecting the neutral wire to the ground screw in an ungrounded receptacle is a dangerous practice known as bootleg grounding. This creates a situation where the neutral and ground wires are connected, leading to several potential hazards. Firstly, electrical hazards. If the neutral wire becomes overloaded or loses continuity, current will flow through the ground wire instead. This can electrify metal enclosures, fixtures, and appliances, creating a shock hazard. People could receive an electrical shock if they come into contact with these energized metal parts. Secondly, equipment damage. Surge protectors and other electronic devices rely on the proper grounding connection to provide protection against overvoltages. Connecting neutral to ground can interfere with this function and damage the equipment. The surge protector may not be able to effectively divert excess voltage, potentially damaging connected electronic devices. Thirdly, fire risk. In case of a short circuit, the excessive current flowing through the ground wire can cause it to overheat and start a fire. The ground wire is not designed to carry large amounts of current continuously, and overheating can ignite nearby combustible materials. Fourthly, voiding warranties. Most surge protectors and other electronic devices have warranties that are void if they are not properly grounded. Connecting neutral to ground violates the grounding requirements and may invalidate the warranty. If the equipment is damaged due to improper grounding, the manufacturer may refuse to cover the repairs or replacement. The effects on surge protectors are significant. Surge protectors are designed to protect electronic devices from overvoltages by diverting excess energy to ground. When neutral is connected to ground, the surge protector's ability to discharge excess voltage is compromised. This can lead to reduced protection for connected devices or even damage to the surge protector itself. The surge protector may not be able to effectively clamp the voltage, allowing harmful overvoltages to reach the connected equipment. Always ensure that electrical receptacles are properly grounded according to local electrical codes. Grounding provides a safe path for fault current to flow back to the source, tripping the circuit breaker or fuse and energizing the circuit. Use only surge protectors that meet safety standards and are designed to be used in the specific application. Look for surge protectors that are listed by a recognized testing laboratory, such as Underwriters Laboratories, and that have a voltage protection rating or volts protection rating that is appropriate for the voltage level of the electrical system. If you are unsure about the grounding of a receptacle, consult a qualified electrician. An electrician can inspect the wiring and ensure that it is properly grounded according to the National Electrical Code, ONEC, and local codes. They can also identify any potential hazards and recommend corrective actions. It's crucial to understand the principles of grounding and bonding in electrical systems. Grounding provides a low impedance path for fault current to return to the source, while bonding connects all metal parts of the electrical system together to equalize voltage potential. These practices help to minimize the risk of electrical shock and fire. In a properly grounded system, the ground wire provides a safe path for fault current to flow back to the source. This allows the circuit breaker or fuse to trip quickly, de-energizing the circuit and preventing a prolonged fault condition. The ground wire also helps to reduce the voltage potential between metal parts of the electrical system, minimizing the risk of electrical shock. Connecting the neutral to the ground can disrupt the intended flow of current in a surge protector. A surge protector is designed to divert excess voltage to the ground wire during a surge event. When the neutral and ground wires are connected, the surge protector may not be able to effectively divert the surge current, potentially damaging the surge protector or the connected equipment. It is important to distinguish between grounded and ungrounded electrical systems. A grounded system has a direct connection to earth, typically at the service entrance. This connection provides a reference point for voltage and helps to stabilize the system. An ungrounded system does not have a direct connection to earth, and voltage can fluctuate more widely. In a grounded system, the neutral wire is typically grounded at the service entrance. This grounding provides a return path for normal current flow and helps to reduce voltage imbalances. The ground wire is connected to the grounding electrode system, which consists of grounding rods, plates, or other approved grounding electrodes. The grounding electrode system provides a connection to earth, ensuring that the electrical system is properly grounded. In an ungrounded system, there is no direct connection to earth. This type of system is less common in residential and commercial applications, but it may be used in some industrial settings. Ungrounded systems can be more susceptible to voltage transients and may require additional surge protection. When working with electrical systems, it's essential to follow all safety precautions and wear appropriate personal protective equipment, or PPE. This includes wearing insulated gloves, safety glasses, and appropriate clothing. Always de-energize the circuit before working on any electrical equipment, and use a voltage tester to verify that the circuit is dead. If you are not comfortable working with electrical systems, it's best to hire a qualified electrician to do the work. An electrician has the knowledge, skills, and experience to safely and effectively install, repair, and maintain electrical systems. They can also ensure that the electrical system complies with all applicable codes and standards. The National Electrical Code, or NEC, is a comprehensive set of standards for electrical installations. It covers a wide range of topics, including wiring methods, grounding, overcurrent protection, and equipment installation. The NEC is updated every 3 years to reflect the latest advances in electrical technology and safety practices. Local electrical codes may also apply in addition to the NEC. These codes may be more stringent than the NEC and may address specific local conditions. It's important to be familiar with the applicable electrical codes before working on any electrical system. Proper grounding and bonding are essential for electrical safety. They help to protect people and property from electrical shock and fire. Never attempt to bypass or defeat any grounding or bonding connections. If you have any questions or concerns about electrical safety, consult a qualified electrician. They can provide expert advice and guidance on how to ensure that your electrical system is safe and reliable. Connecting the neutral to the ground screw is a shortcut that can have serious consequences. It's not worth the risk to save a few dollars or a few minutes. Always do the job right and ensure that the electrical system is properly grounded. Here is an example of a situation. Suppose there is a fault in an appliance where the hot wire comes into contact with the metal chassis. In a properly grounded system, this fault would create a low impedance path for current to flow back to the source, tripping the circuit breaker or fuse and energizing the circuit. However, if the neutral and ground wires are connected, the fault current may flow through the ground wire, potentially electrifying the metal chassis of the appliance. This could create a shock hazard for anyone who comes into contact with the appliance. In addition to the shock hazard, connecting the neutral to the ground can also create a fire hazard. If the ground wire is not sized properly to handle the fault current, it can overheat and ignite nearby combustible materials. This is especially true if the ground wire is connected to a gas pipe or other flammable material. Surge protectors are designed to protect electronic devices from voltage spikes and surges. These devices typically contain metal oxide varistors, or MOVs, that divert excess voltage to the ground wire. When the neutral and ground wires are connected, the surge protector may not be able to function properly. The surge current may flow through the neutral wire instead of the ground wire, potentially damaging the surge protector or the connected equipment. To ensure proper grounding, it's important to use the correct wiring methods and grounding components. The NEC specifies the types of wiring and grounding electrodes that are permitted in different applications. It also specifies the minimum size of the ground wire and the methods for connecting it to the grounding electrode system. When installing electrical receptacles, it's important to use a receptacle tester to verify that the receptacle is properly grounded. A receptacle tester can detect common wiring errors such as an open ground, a reverse polarity, or a hot neutral reversal. If the receptacle tester indicates a wiring error, do not use the receptacle until the error has been corrected. In some cases, it may be necessary to install a ground fault circuit interrupter, or GFCI, receptacle. A GFCI receptacle is designed to protect against electrical shock by detecting small imbalances in current flow. If the GFCI receptacle detects a current imbalance, it will trip and de-energize the circuit. GFCI receptacles are required in certain locations, such as bathrooms, kitchens, and outdoor areas. When working with electrical systems, it's important to be aware of the potential hazards and to take appropriate safety precautions. Always to energize the circuit before working on any electrical equipment, and use a voltage tester to verify that the circuit is dead. Wear insulated gloves and safety glasses, and avoid working in wet or damp conditions. If you are not comfortable working with electrical systems, hire a qualified electrician to do the work. They can ensure that the electrical system is safe and compliant with all applicable codes and standards. Electrical safety is a serious matter. Taking shortcuts or ignoring safety precautions can have serious consequences. Always do the job right and ensure that the electrical system is properly grounded. Connecting the neutral to the ground is a violation of electrical code. Electric codes such as the National Electrical Code, or NEC, are in place to ensure safe electrical practices and installations. Bypassing these codes can lead to unsafe environments and situations. Grounding and bonding are critical for electrical safety. Grounding provides a path for fault currents, while bonding ensures electrical continuity and reduces shock hazards. Tampering with these systems can have dangerous consequences. It is important to use properly rated equipment. Electrical equipment, including surge protectors and receptacles, must be rated for the intended voltage and current. Using underrated equipment can lead to overheating, fire, and equipment failure. Proper wiring methods must be followed. Electrical wiring must be installed according to code-compliant methods. This includes using the correct wire size, conduit, and connectors. Improper wiring can lead to shorts, overloads, and other electrical hazards. Regular inspection and maintenance are important. The electrical system should be inspected and maintained regularly to identify and correct potential problems. This can help to prevent electrical accidents and ensure the safe operation of electrical equipment. Remember to consult with a qualified electrician. If you have any questions or concerns about electrical safety, consult with a qualified electrician. They can provide expert advice and guidance on how to ensure that your electrical system is safe and reliable.